Let's solve this challenging implicit differentiation problem step by step. We need to find dy dx when x raised to y equals y raised to x. Let's start by taking the natural logarithm of both sides. This will help us simplify the exponential expressions. Using the logarithm property that log of a power equals the power times the log, we can rewrite this as y ln x equals x ln y. Now comes the tricky part. We need to differentiate both sides with respect to x. On the left side, we'll use the product rule since we have y times ln x. On the right side, we'll have x times the derivative of ln, y plus ln, y times the derivative of x. Putting these together, we get this equation. Remember, since we started with an equality, the derivatives must also be equal. Let's rearrange to get all terms with dy dx on one side and all other terms on the other side. First, subtract x over y times dy dx from both sides, and subtract y over x from both sides. Next, let's multiply both numerator and denominator by y in the first bracket, and multiply both terms on the right by x over x to get common denominators. Finally, we can solve for dy dx by multiplying both sides by y over y ln x minus x and x over x ln y minus y. And there we have it. We found dy dx in terms of x and y. This was a challenging problem that required careful use of the product rule, chain rule, and algebraic manipulation.